Good morning. I am Prashant of CSC C section BTech first year. Today I am going to give a presentation on optimization tips for Python. So first let us learn about what is Python. So Python is this popular and widely used high-level language for general purpose programming. It was created by Godot van Duzum and first released in 1991. So Python is known for its simplicity. So Python has a simple, easy to use and readable syntax, making it easier to understand and write compared to many other programming languages like C, C++. So one of the best features of Python is how simple it is to learn and how consistent it is across a wide range of applications. So Python has evolved into this versatile and dependable programming language for modern computer needs since 1991. So this undoubtedly makes Python popular among developers. So according to Statista, almost half of all the developers in the world use Python. So now let's get to some common Python performance issues. Okay. Now, before we get into Python optimization tips, it is important to look into the reason that makes Python slower than computers. Because if we don't know the disease, we can't tell the cure. Okay, it is same like that. So some of the common Python performance issues are Python speed issues, Python's an interpreted language, Python is dynamically typed, Python can cause inefficient memory utilization, and Python doesn't support concurrency. So now let's get to the first one, Python speed issues. So many hardware features were made using the hardware available at that time. So adapting the language design to the hardware technology available now is a very time consuming process. But although Python can be torn down and rebuilt, making changes can improve its core design, making it compatible with future Python versions. Point number 2, Python is an interpreted language. Python is frequently interpreted, which is one of the most significant differences between it and other languages. So the main difference between interpreter and compiler is compiler compiles all the code while interpreter compiles only the necessary code. So for example, if I am Modi and I talk in Hindi but you only understand Telugu, compiler compiles all of my speech once I speak it and then gives you speech. But interpreter translate the Hindi to Telugu line by line. Okay, so Python is an interpreted language while C uses a compiler. Okay, so since C uses compiler, it first converts the source code to directly to machine code, but Python works a little differently. Okay, source code is not compiled into machine code but into byte code. Then the interpreter compiles the byte code into machine code. But interpreter converts only what is needed into machine code, not like compiler. It doesn't compile all of the code. So point number 3, Python is dynamically typed. So because we don't specify the type of variable beforehand, we have to wait before it determines what we are doing, if what we are doing is legal. Like for example, if we give apple to Python, it doesn't know that it is a fruit. Okay, because it is dynamically typed. So it takes time to know if apple is a fruit or a vegetable or a leaf or root. But in C we have to define what is apple. We have to define that it is fruit. So it is faster to compile in C, in languages like C. The interpreter in dynamically typed languages like Python has no idea if it is a fruit or a vegetable or a root. So it will require more work to identify that it is a fruit. So this makes Python slower compared to compiled languages like C. So here, for example, in C we write int of a is equal to 0, int of b is equal to 1, then int of sum is equal to a plus b. But in Python we don't define the variable. For example, a is equal to 0, b is equal to 0, then sum is equal to a plus b. We don't define that a and b are integers. So that is the main difference between Python and C. See, the C code would consistently outperform the Python version in terms of performance. Okay, because the because we explicitly declare the runtime environments. We declare that it is a is an integer or apple is an fruit, so it doesn't take as much time to recognize the variable, and it also increases the efficiency. So since we don't define apple as a fruit or a as an integer, it takes extra steps for Python to identify it, making it less efficient. So point number 4, Python can cause inefficient memory utilization. See, because Python lacks correct types, performing simple activities like performing several redundant takes performing several redundant. So point number 4, Python can cause inefficient memory utilization. Because Python objects lack correct types, performing simple activities creates multiple steps, multiple actions. Okay, so lists are stored differently in Python. A list a list object in Python contains a reference to contiguous array of references in memory. So these links will take you to an actual data. This can lead to tangled situation similar to this in the image. So point number 5, Python doesn't support concurrency. Okay, this isn't much of a setback to Python because most programming languages allow you to take advantage of several processing cores that come equipped with current machines. Concurrent access to a variable must be closely controlled, which is one of the most significant challenges this behavior brings. Okay, now let's get to Python optimization tips and tricks. These tips and tricks for Python code performance optimization lie within the realm of Python. The following is a list of Python performance tips. Tip number 1, use built-in functions and libraries. Okay, so built-in functions, the map function applies to a function to every member of a tuple and returns the result. If there are multiple arguments, map returns a list consisting of tuples containing the corresponding items from all iterables. So, for example, here we have the slower version without the map. Start is equal to time.clock, s is equal to gigs, u. For c in s, u dot append of c dot upper, print u. Elapsed is equal to time.clock, e1 is equal to elapsed minus start. Print time spent in function is e1. So now the faster version, s is equal to geeks, start is equal to time dot clock, u is equal to map of str dot upper comma s, print u. Elapsed is equal to time dot clock, e2 is equal to elapsed minus start. Print time spent in built-in function is e2. So the output is GEEKS. So the time spent on this function is 0.039474 seconds. So the second output is GEEKS. The time spent on this built-in function is 0.0212335 seconds. So this is like 1/100th of a second difference. Does it make any difference to me? To me it doesn't make any difference, but if you write hundreds of coding lines, then it might make a difference to you. So the packages are platform specific, which means that we need appropriate package for the platform we are using. So for example, we use a function called deck. So from collections, import deck, s is equal to geek. So d is equal to dec of s, then d dot append y, then d dot append left h, print d dot pop left. So print list reverse d. So the output we get is dec of h, because we append h on the left, g e k y, because we append y on the right, and because of the second function d dot pop and d dot pop left, and because we reverse the list, we get k e e g. So use keys for sorts. So in Python we should use the key argument to the built-in sort instead, which is faster way to sort. So here Python program to illustrate using keys for sorting. For example, we have sum list is equal to 1 minus 3 6 11 5. Then sum list dot sort. We get then print sum list. We get the output as minus 3 1 5 6 11. Here we get sorted because it is sorted according to the index numbers. Okay. Then we get then the program s is equal to geeks. Then s is equal to sorted s. Print s. Then we get e e g k s. So in each case the list is sorted according to the index we select as part of key argument. Okay. Optimization loops. Okay, write idiomatic code. This may sound counterintuitive, but writing idiomatic code block will make your code faster in most cases. Okay, for example, here we have string concatenation. S is equal to hello geeks. S list is equal to, for I in S list is equal to S list plus I. So print S list. Okay, here we get the output. So st is equal to hello geeks. St list is equal to open quote close quote dot join for I in S, print S list. So better way to iterate a range. Events is equal to I for I in range of 10 if I divided by 2 is equal to 0. Print events. Hashtag less. I is equal to 0. Events. While I less than 10, if I mod of 2 is equal to 0, events dot append I plus is equal to 1, print events. So hashtag slow version means slow. V is equal to for slow. S is equal to geeks plus V plus geeks, print S. Faster version. S is equal to geeks mod S geeks mod V, print S. So the output is hello geeks, then 0 2 4 6 8, then geeks for geeks. So every time running a loop to s of I, Python evaluates the method. However, if you place the evaluation in a variable, the value is already known, Python can perform tasks faster. Using multiple coding approaches. Using precisely the same coding approach every time we create an application will almost certainly result in some situation where the application runs slower than it might. For example, initializing dictionary elements. My dict is equal to G is to 1, E is to 1, E is to 1, K is to 1. My word is equal to geeks for geeks. For W in my word, if W not in my dict of W is equal to 0. My dict of W plus is equal to 1. Print my dict. But the faster version. My dict is equal to G is to 1, E is to 1, E is to 1, K is to 1. So my word is geeks for geeks. For W in word, try my dict of W plus is equal to 1. Except key error, my dict of W is equal to 1. Print my dict. So the output is E is to 5, G is to 3, F is to 1, K is to 3, O is to 1, S is to 2, R is to 1. The output is same in both cases. The only difference is how the output is obtained. So in the latter case, the output is obtained faster. Using exchange instead of range. Okay, range function. This returns a list of numbers created using range function, xRange function. This function returns the generator object that can be used to display numbers only by looping. Only particular range is displaced on demand and hence called lazy evaluation. Okay. X is equal to I for I in range of 0, 10, 2. Print X. But in faster version, I for I in range of 0, 10, 2. Print X. Output is 1, 3, 5, 7, 9. This could save system memory because X range will only yield one integer element in a sequence at the time. Whereas range, it gives you an entire list, which is unnecessary overhead for looping. Use Python assessment to swap variables. This is elegant and faster in Python. For example, x is equal to 2, y is equal to 5. Here temp is equal to, or you can take any variable x is, temp is equal to x is equal to y is equal to temp. Print x is equal to y. We get the swapped variables x comma y is equal to 5 comma 2. xy is equal to 3, 5. Oh. So second program, x comma y is equal to 3, 5. Faster. X comma y is equal to y comma x. Print xy. This is obviously faster than the first one. Use local variables if possible. Python is faster retrieving a local variable than retrieving a global variable. This is to avoid global, that is to avoid the global keyword. So for example, class of test definition function self comma x, print x plus x. Object is equal to test. My test is equal to object dot func. N is equal to 2 for I in range of n. My test 1. So the output is 0 comma 2. 0 and 2. So wrapping up, I hope that Python performance optimization tips given in this PPT can help you build faster Python applications. These Python optimization tips will help you run Python code more reliably at numerous levels of granularity. So thank you.